Hello sir, so for this video we're gonna make for part B. Okay, so now is the question for part B1. So I've already typed the code into the Visual Studio, and now I'm gonna debug it line by line. So before that, the question is here. So this is the question. So I already complete the question, so we're just gonna go line by line like this. Okay, so first of all, for line 1, we move the value of var1, which is 1 decimal, into register AX. Okay, you know, so the value of AX into the register, value of var1 into the register. And now for line 2, we move the BX, we move var2 into BX. Okay, we move var2 into BX. Now line 3, we exchange the value of AX and BX. Okay, and then line 4, we move the value of AX into var1. Okay, and then line 5, we move the value of BX into var2. Okay, so let's see. So now we move the value of AX, we move the value of var1, var1 0001 into the AX 0001 H, as hexadecimal. And now as you can see, BX now is 8. This is the initial value of BX. Now we're gonna move var2, which is 0009, into the BX. Okay, yes, you can see here. And then when you exchange the value of AX and BX, we're gonna change, which means that the value of AX become BX and the value of BX become AX. Okay, here you can see. And now we move the value of AX into var1, and remove BX into var2. There you go. So that's the end of question 1. Okay, here. Alright, sorry. Okay, now we're gonna stop debugging, and we move to part B, question 2. Okay, so I forgot to change this. Okay, so for part B, question 2, we have the arithmetic expression. So how can we create this arithmetic expression in the assembly code? So this is the way. Alright, so we first initialize all the variable using the word, and then okay, first of all, we will move the value of x val, which is 26, into the register EAX. Okay, and then we negate the value of EAX. Then we move the value of y val into EBX, and then we subtract the value of x val from EBX. Okay, then we add the value of EBX into EAX and increment the value of EAX by 1. Okay, as you can see here, this is the increment. Okay, and then we move the result into our value. Okay, so let's just go. Okay, now we're just going to debug. Okay, alright, first of all, as you can see, this is the initial value of EAX. Okay, and then we're gonna move this value into EAX there, and then we negate it. Okay, we negate the value from here to here. Okay, and then we're gonna move the y val into the EBX. Okay, then we subtract EBX with x val. Okay, and then we're gonna add EAX and EBX. And then we increment EAX. Then we move the value of EAX into R-val, which is 0. Okay, so this is the final answer. Alright, so I'm going to just stop debugging and let's move to part 3. Part B, question 3. Okay, so for part B, question 3, we are given this table 3, which stated the value of the initial value that we should put into the register. So for EAX, we're going to put 10H, EBX 20H, ECX 2H, EDX 0H. Okay, so after that, we're going to execute mul BX first, and then mul CX, mul X, and so on. Okay, so I've already done in here. Alright, so first of all, I've already moved the initial value 10, 20, 2, and 0. Okay, so first of all, we're gonna do the mul BX first. Okay, let's debug it. Okay, alright, so so first we're gonna initialize the register. There you go. And okay, all the registers are initialized now, 10, 20, 2, and 0. Okay, so what mul do is it's gonna multiply the value of EAX. So in this case, if you use BX, you can multiply the value of AX. Okay, with BX. Right, so there you go. Okay, so the value of EAX become 200. Okay, before it is just 10, but 10 times 20 become 200, right? Okay, let's stop debugging, and then we're gonna do for mul CX. Okay, for this one, I'm just gonna go fast. Okay, from 10 become 20, because 10 times 2 is 20. Okay, go again. Oh, okay, from 10 become 100, because in hexadecimal, oh yeah, it is 10 times 10. Okay, math times 10 times 10 is 100. Okay, then we're gonna continue with division. So okay, division, first we're gonna divide with BX. Okay, okay, initialize all the value of register. Okay, and then from 10 become 10 we divide by 20, it will become 0. Okay, okay, then we're gonna stop. We're gonna move to CX. Okay, so it will become 8. Alright, okay, from 10 become 1. Alright, so for this part here, I'm not going to do it again, because what difference is that it's only with the amount of bit. because this one is using the EBX, which is the standard register, and it has 32 bit, but this one is only have 16 bit. Okay, so that's all for part B3. Okay, now we're gonna move to part B4. Okay, so part B4. Okay, so part B4, we have an expression again. Okay, so this one is var4 is equal to var1 times var2 in bracket plus var3 also in bracket, and then minus 1. So how are we gonna implement this expression into the assembly code? So this is the way, but this code is not actually complete because we didn't move the final value into the var4. Okay, so we're just gonna go through one by one. Okay, so first of all, we have initialized on the value of variable. Okay, and then first of all we're gonna move the value of var1 into the register EAX. Okay, so let's see. There you go. I'm sure I'm gonna remove this one. Okay, so var1 into EAX, and now we're gonna multiply EAX by var2. There you go, var32, and then we add var3 into EAX, and then we decrement EAX. Okay, by 1 it become 45. Alright, so let's say for part B4, then we move to part B5. Part B5 also as arithmetic expression, and then we have var1 times 5 divided by var2 minus 3. Okay, so this is the coding here. So I've already written the code into the various student code, so let's just see it. Okay, so this is the arithmetic expression. Now we're just going to debug it. Okay, alright, first of all, what we're going to do is we're going to move var1 into AX. Okay, then we move the value of 5 into BX, then we multiply AX by BX, which is 5, and then we move the value of R2 into BX, and then we subtract BX by 3, and we divide BX. We divide AX with BX. Then we move the final value AX into R4. So the final value is 001C. Okay, in decimal we got 28, right? Okay, so that is all for part B. Thank you.